Processing uses all kinds of techniques to help you write really good code. And it uses those techniques to also help you understand your code or someone else's and help you fix it when it goes wrong. One of those bags of tricks is to use color in all kinds of ways. Now, the particular colors that it uses for every one of these steps is customizable by you. But when you download it, it comes with a set of default colors. So I'm going to show you what happens with mostly the default colors on the Macintosh under the current release of processing. But keep in mind that these choices of colors can vary from one system to the next, and they can vary from one release to the next. And if you don't like them, you can change them. So these are the colors I'm using now. Here's a piece of code that I wrote the other day. Now, don't try to read it. Don't try to understand it. That's not the point here. The point is just to let your eyes kind of glaze over, but look at the colors of the text. Some words are in black. Some words are in orange. Some words are in blue. And some words are in gray. And those 4 different colors let you spot stuff that's happening in your code. I'll just sort of scroll through here, and you can see this is all automatic. Processing is figuring out what colors all these words ought to be by itself and applying those colors. And it just helps you take in the structure of your code at a glance. So let's see how this works. Here's a blank sketch, and I'm just going to use it as a text editor to show you how processing recognizes words and colors them appropriately. So if processing doesn't know a word, it just types it in black. So for example, it doesn't know the word frog. And if I type frog, it shows up in black. Now there are a few dozen words that are special to processing. They're called keywords. And the keywords are the words that processing uses to define the language. So if you've seen the video on print, you know that print is a keyword because we use that string of letters, P-R-I-N-T, to tell the computer, here's something I want you to print. Well, let's see what happens when I type print. If I type P-R-I-N, well, so far we don't have print yet. What we have is prin. It doesn't know what prin is. It's fine with that. As soon as you hit the T, it says, wait, I know what that is. That's print. That's one of my words. And it automatically flags it in orange. Now, if I keep going and I type printing, it goes back to black. So the keyword is only recognized if it's by itself. There are no more letters to the left or the right. There's another kind of keyword that gets a slightly different behavior. Here's mouse followed by a capital X. It's a little weird. Notice that that keyword gets flagged in blue. So there are orange keywords and there are blue keywords. There is a rule for telling them apart, but the rule is not applied entirely consistently. In general, if a keyword is in blue, that means it has a value, a numerical value. Like in this case, mouse X has a value like 13 or 112, and we'll talk about that when we talk about the mouse. Everything else is in orange. That rule is probably held to 90 or 95% of the time. Every now and then, you'll find that something you might think should be blue will show up orange. Something you think should be orange will show up in blue. I recommend not getting too hung up on the weird cases and just sort of sticking to the general idea that orange and blue are for keywords, and most of the time, blue means it has a value, and orange means it's something else. Here's the exception to that rule. Character strings are also in blue. So if I have the name of Amelia Earhart, notice that that's enclosed in double quotes. That is also in blue. If you have a single character, you can enclose it in single quotes, and that also will show up in blue. And we'll learn the rules for strings later, but this way you can see a string of letters in quotes also shows up in blue. There's an interesting thing that happens when you type such a string. Let's open it up and start typing. Notice that it's gray. That's processing's way of saying you haven't hit the closing quote yet. If I keep going, it says, well, there's still no closing quote. Now you've closed the quote. And now I'll make it blue. And so that's nice when you're typing a long thing and you're not sure if you've hit the closing quote or not. And in fact, if you forget the closing quote, your program won't run right. It probably won't run at all. And you'll be able to spot that you have a problem because you won't see a blue character string. You'll see gray stuff. Finally, we had gray, which we saw before. Gray is for comments. So there are several ways of writing comments, and we'll see that later. But one of them is to begin with 2 slashes on a line. And if you type 2 slashes, then you can type anything you want. And the computer will simply ignore it. It just pays no attention to it at all. It shows it to you on the text editor, but as far as it's concerned, that's not part of your program. It doesn't try to run it. It doesn't even try to understand it. Notice if I put the word print in there, it doesn't turn orange because the fact that it's a comment supersedes everything. It says anything that's a comment, I just don't even pay attention to. Mouse X, Sam, everything that's a comment is gray. So that's color coding in the text editor window. There's color coding in 2 other places. The message bar here is normally gray, and that's telling you everything is fine. The big black output area down here is normally empty, and that's telling you everything is fine. Let's print something out. Now, if you saw the print video, you know how to do this. If you haven't, just bear with me. I can say print hello. That is a tiny little program that simply tells the computer print hello. And to learn more about print, watch the print video. So if I hit the run button now, processing will do what I've asked it to do, and it will print the character string hello to the output. And if we look down here, we see the output. And it's white text. Beautiful. So white tells us I'm printing out something you asked me to print out. But this area is also used for error messages. So let's do something wrong with our program. I'm going to leave off that closing semicolon, which as far as the computer is concerned is an unforgivable error and it will get upset. So let's go ahead and let it be upset. I'm going to try to run the program without a semicolon at the end. So I hit the run button and 2 interesting things happen. Actually 3. The first is the line that had a problem in it is highlighted in orange. That's because that's my highlight color. I set it to be a bright yellow-orange color for you. But whatever your highlight color is, the line that caused the problem will be highlighted. Next, the window that gives you that 1-line error message turns red. Remember, this used to be gray. Now it turns red, and it has an error message on it. Don't worry about the message now. We don't care. But just notice the bar turned red, and there's a message. That's to tell you there's a problem. Finally, processing will give you the details on the error down here, and it will use red type. And the red type says this is error message stuff, because remember, your output is in white. If I fix the program, then the error bar goes back to a calm shade of gray. The red type goes away, the white type shows up, and our program is successful. Finally, notice that when the program is running, the run button is yellow, and that's telling us I am actively running. As soon as I click on the stop button, the run button goes off. And that's how processing uses colors to help you understand the structure of your program and notice when things go wrong.